There are a ton of text manipulation tools for the Linux command line. In fact, manipulating text is one of the things that there are just so many tools that can be overwhelming, and that's okay. What I want to show you in this video is exactly how you can do some simple text manipulation to like pull data out of text files. And it's okay if you don't remember all of the command line flags for like the cut command and the sort command and the word count command and all of these other tools that we're going to use, because generally when you do them, you have to like look at the man page or Google it anyway just to refresh your memory. The only time you're really going to need to remember the specific flags and how to use them is if you're planning to take an exam, like for the Linux Essentials certification. Then you might actually want to study up on these tools that we're going to look at just to refresh your memory about the like different command line arguments that you can use. But don't focus too much on memorizing them, because it's really more important for you to understand that you can do these things and that there are tools that let you do it. I'll show you those tools, but again, don't get too stressed out if like you don't remember the exact command line flag for the cut command. Just know that if you're taking that test, you might want to study up so you remember. Anyway, all that said, let's go. And I think the best way to do this is to just go to the command line with a text file and just start cutting it up and stuff. And so that's what I have right here. I have this text file. We'll refer to this. This is the text file that is in our folder right here. Dang it. There, okay. It's here. If we look, it's called fruits.csv. And if we look at fruits.csv, we can see this is the exact same information that's over here. I just wanted to have this open so we could refer to it while we're doing different things. Okay, so let's clear this. The first tools I want to show you are head and tail. These are really useful if you're looking through log files and you just want to see like the end of a log file. And how they work is head will look at the top of a text file and tail will look at the bottom of a text file, which makes sense, head and tail. But you can make it do things in different ways. For example, if we were to say head and let's say -n for the number of lines from the top of the file, and we say 5 lines from fruit.csv, it should just show us the first 5 lines of that file. And if we do that, enter, and sure enough, we have the first 5 lines. Here they are, 1, 2, 3, 4, 5. And if you look, they match the first 5 lines that are over here in our document on the side. Just again, that's just a reference document. So we can look at just the first 5 lines. Tail is just the opposite. We can say tail dash number 3, for example, fruits. And we should see the last 3 lines. And sure enough, that's what we see, the last 3 lines. Now, by default, I think tail uses 20 lines. So if we were to say just tail fruits, it would just show us the whole thing, because there's not enough lines for it to just show us like, it's showing us like the last 20 lines, but there's not 20 lines. So if you want to specify how many lines to see, you do -n and then the number. This is something that I use all the time when looking at log files. I'll look at the tail of a log file, so I don't have to look at like thousands or sometimes hundreds of thousands of lines of logs going back who knows how long. I can just look at the very end that was recently written to. So that's where that's really, really useful. You can also do some other crazy things, like let's say we wanted to see all of the lines past the 3rd line. So you can do tail dash the let's see, the number of lines, and then from, I got to look at my keyboard here. I'm not good at these. All right. Plus, let's say 2, okay, of fruits.csv. What this is going to do is it's going to go to the 2nd line of the file and show us everything below that. And that'll be really important in just a second. But we'll see here, sure enough, it started with the 2nd line. If we look over here, the 2nd line is orange. And that's what it gave us. It gave us orange all the way down to the end. And it wouldn't have mattered how long it was. It would have gone all the way to the end with that command -n plus 2. Okay, so the reason we want to do that is because our next command that we're going to look at is called sort. All right, sort does just what you would think. So let's clear the screen. And if we just say sort fruits.csv, it will put our file in alphabetical order, which is really, really nice, right? It's nice to have things in alphabetical order. And it just did it, by the characters. It did them, one by one. It did not matter about the case. It didn't care if it was, capital or lowercase. And what we have, apple, avocado, banana, grape, honeydew, lemon, name, color, size, orange, watermelon. And of course, you see the problem here, right? The top line of this CSV file is the header line, and it alphabetized it, but we obviously don't want that at the top. So that's where we can get a little bit crafty. And I'm going to tie a bunch of things together with pipes and redirects. Are you ready? Okay, so what we want is, first of all, the very first line of the header we want to be on the top. So we could do that with head. We could say head dash N1 fruits.csv, and that should just print out, sure enough, just that first line. Okay, so we want that at the top. And then if we wanted just the tail, well, we actually did that right up top, right? We did tail dash N starting with line 2 of fruits.csv. And there we have all of those without the header printed. Okay, so if we put these together, first of all, this is just like a not part of this thing, but if you use the semicolon, you can put 2 commands on one line. So if we were to do ls and then a semicolon and then ls, it'll just do it twice. Okay, it just did ls, and then when that was finished, it did the next command, ls. You can just string a bunch of things together doing that. So we could say ls echo hello ls. And so it did fruits, hello, fruits. So you can string things together like that. So now let's get crafty. Clear the screen. So now, first of all, I want that header. So I'm going to say head-n1 fruits.csv, and that will give us that line. Okay, so that's the output. Okay, that's the first line that we want output. So I put a semicolon, and now the next thing I'm going to do is do the tail part. So tail-n starting with line 2, so +2 of fruits.csv. And then the results of that, I'm going to pipe into sort. So we have 2 separate commands here. This head-n1 fruits.csv before the semicolon here, that's going to execute and then be done. But it's not going to give us a new prompt back. It's going to immediately execute the next thing, which is tail-n+2 fruits.csv piped through the sort command. Okay, so it's just piping the results of the second one through the sort command, and that should give us a nice, refreshing, because they're fruit, list of our stuff. Let's see, hit enter. Let's see if it worked. We have, sure enough, the header line is right at the top. So name, color, size, and then apple, avocado, banana, grape, honeydew, lemon, orange, watermelon. So it did exactly what we wanted. We sorted this in alphabetical order and kept the header at the top. So that's the kind of cool stuff you can do using these text manipulation tools, but you have to get crafty and string things together. And thankfully, sort is one of those commands that accepts things on standard input and then puts the results into standard output. All right, so that is how sort works. We could also do reverse sorting. This, I just pushed up arrow to get that whole string that we typed in, and we could do sort-r, and sort-r just means put them in reverse alphabetical order. So with this one, we should start with watermelon and end with apple. Let's see if that's what we get. Sure enough, we got the header because, again, we did that head part first, and then we started with watermelon, and it went in reverse alphabetical order all the way down to apple. So that's actually pretty cool how it works, right? It's, sort's kind of neat. And you can look up sort, you can look up the different things you can do with sort. You can sort, case sensitive, not case sensitive. You can do different things when numbers come into play. Just look in the man page if you want to get more specific, but this is enough to understand the sort of things that sort can do. All right, I'm going to clear the screen because the next one that we're going to look at is called cut. Now, cut is pretty much what you think. It takes every line in the file and it will cut it up like you tell it to. Okay, so first of all, let's do cut -- help, because I want to show you a couple different things that you can cut by, if you will. So the -b, you can specify how many bytes of data you want for the start and the finish. I usually don't do that because bytes are generally 1 character, but I really usually want it to be characters. So I'll do -c and specify number of characters. Okay. We can also do delimiters. Delimiters are what we'll look at again. And that's where if you look right here, because it's still here, we have like a list and it's delimited by commas. So we can have it cut by fields instead of specific characters as well. So let's hit enter. I'll clear the screen again. And what I want to do is I want to cut -c for characters because I want to cut by characters. And I want just characters 1 through 3 of the file fruits.csv. Okay, this should give us the first 3 characters of every line. We hit enter, and you have to spell cut right. I put an R after that. Yeah, that was just a typo. So cut-c 1 through 3 fruits.csv, hit enter, and sure enough, we just got the first 3 characters of every single line on it. But it doesn't have to start at 1, right? We could do something else. We could say, let me clear the screen. We could say cut dash characters 5 through 9 of fruits.c, and now we should get the same thing, but starting with character 5 and go all the way to character 9. And you'll see where going by characters is a little bit not great unless it's a fixed width thing that you're looking at. Then you could do by characters, but ours are not fixed width because we have our different fields are separated by commas, and some of these have commas at the front and the back, and it just gets really ugly. So what we can do is tell cut to use delimiters. Now, by default, it uses tab as a delimiter, but here, let's clear the screen. So what we do is say cut, and I want to use the delimiter, so -d of comma. And we just immediately after the D, we put what delimiter we want. So using that delimiter, I want you to use -f for what field we want. And we want, let's say I want field 2 of the file. So what we should get here is the word color from the header. So color, orange, green, red, red, yellow, green, green, yellow, green. Let's see if that's what we get. Sure enough, color, orange, red, or green, red, red, yellow, green, blah, blah, blah. Just like I said. And what it did is it just gave us that field number 2 from our text file that was delimited by commas, which is actually really, really cool. So that's really useful, and we can use that a lot to get a specific field out of our data. Now, again, we could string this along with that head and tail command if we didn't want that very first header field or that header line. We could get rid of that by using like tail -n+2 to start at the second one, and then pipe the output in that into cut and have cut use standard input, etc., etc. You get where I'm going there. Okay, so that is cut. Now, the next one is one that you're going to use all the time, and we're just going to touch the basics of it. It's called grep. You've probably heard of grep before. Let's clear the screen one more time. And grep can be very, very simple. What it does is you say, I want to find this matching pattern of text in the text file that I'm going to feed you, or in the bunch of text I'm going to dump into your stdin, your standard input. And I want you to show me every line that has that chunk of text that I've described in it. And you can do it simply with just like a word. So we can say grep for red from fruits.csv. And in this case, it'll show us the lines that have the word red in them. Here's red, and it shows it. Now, this is nice on this GUI interface. It actually highlights the things that it found. So that's really nice. We can see why it found it, because sure enough, red is what we searched for, and it found red right there. It's very, very convenient. But we can do more than just search for red. Let's say we're going to look for red all capitals. Nothing. And that's because by default, grep is case sensitive, but we can tell it to be case insensitive by doing grep-I for insensitive, case insensitive in this case, red from fruits.csv. And now it will find them because, again, it's case insensitive. And we could have done like capital R, lowercase e, and it would have found any red in there regardless of the case of the text. Okay, so that's actually pretty cool. We could also do a little bit of, now this is going to get scary. This is the scariest part of the whole video, I promise. We're going to do just a tiny bit of regular expressions. And the reason that we're going to do this is because I'm basing these videos on the Linux Essentials objectives, if you want to get certified in that. And they specifically, let's see if I can show you right here, they specifically mention a few of the basic regular expressions that grep can handle. So the first one we're going to look at is, if we do grep a P, and then open brackets, PE, fruits.csv. Now, what the brackets mean is anything in that bracket. So either P or E will be considered a match. Okay, so anytime it finds APP, it should return a match, and anytime it finds APE, it should return a match. So it's either one of those things inside the bracket. Okay, let's see if that's what it does. Let's see, it found APE in grape, APE in grape, and APP in apple. Okay, so that's exactly what it did. It used the stuff in the brackets and it said either one of these will be considered a match for what I'm searching for. So that's really, really a nice way to go. Another one we can do is the period. So grep, I gotta spell words right. grep.ap from fruits.csv. So what the period means is any character, but not no characters. Okay, it has to be a character. If there's a dot there, it can be any character in the whole world, but there must be a character in that place or it won't match. And we'll see how that turns out. We press enter. It's going to find that something AP, in fact, in this case, it found RAP in grape and RAP in grape here. However, it did not find this. If you look over here on the left, it did not find the AP in apple because there's nothing before that AP, right? This dot over here specifies that it has to have a character before the A. It can be any character, but there has to be a character before that A. And in this case, there was no character before the A in apple. So it did not match and it only showed us the two grapes right there. All right. Hopefully that makes sense. Another one that I want to show you is the asterisk. Okay, so if we do AP star L, fruits.csv, now, an asterisk means that the previous character to the asterisk, so in our case, the P, it can exist 0 or more times. So it can exist 0 times, or it can exist multiple times, or 1 time, but there has to be 0 or 1. Now, what does that mean? Let's hit enter. Okay, so it found multiple things here. It found this AL because there were 0 or more P's, right? There were 0 P's. So A, 0 P's, and an L. So it found this AL. Same thing in this word small. It found AL. But then it also matched this APPL because it said, again, with this asterisk, there can be 0 or more of that character. So it found multiple P's, and so then it matched the APPL. That one doesn't seem like it's as useful, but it can be very, very useful. But you have to understand that it's different than globbing. If you remember in previous videos, we talked about globbing, like if you do ls star dot star, it's going to match all those things. That is not what an asterisk means in grep. In grep, it means 0 or more occurrences of the previous character in this inside the quotes that we did here. So that's really important to understand. It's different than wildcard globbing. It's actually regular expressions. And then here's something that is a little bit frustrating for me. We just have one more. I told you this was scary, but it's not too bad. The one other one that they specifically mention in the Linux Essentials objectives is an extended regex. It says like you have to learn basic regex like these things, and then it listed one of them that is extended regex, which is frustrating for me. So anyway, that one is this. I'm going to clear the screen since this is going to be, we're delving into extended regex. So you have to do grep -E, EL, question mark is the character in question. Okay, I'm going to show you the results and then explain what's going on here. Okay, what a question mark means is the previous character, so L in this case, has to exist 0 or 1 times, but not more than 1 time. So like remember with the asterisk, it was a 0 or more. So that's why it found that PP in apple. With a question mark, it's just 0 or 1 time. Okay, so it found ELON for watermelon. But there's one here that it doesn't match. But it does not match this yellow. Now, why doesn't it match yellow? ELLO. Okay, there's more than one L. And remember, the question mark can only match 0 L's or 1 L, not 2 L's like in yellow. So it did not match the word yellow. It only matched this in watermelon. Whew, it gets confusing. And this is just the very edge of regular expressions. Regular expressions can be very powerful, and we'll cover that later on together. But for right now, that's all the regex you need to know. And then I'll finish off with a really easy one. This is WC. So let's do a quick wc help. And what we can do is do a word count, and it will count the number of lines, it will count number of characters, number of bytes. One of the ones that I use most often is the number of lines that are returned, and I'll show you what I mean. All right, so let's clear the screen. And if we do wc-l of fruits, it tells us there are 10 lines in that text file, fruits.csv. Okay, hopefully that makes sense. Now, if we were to do something like grep for green from fruits.csv, how many lines are returned here? Let's count them manually. 1, 2, 3, 4 lines are returned. But if we do that same thing and then pipe it into word count -l, it should give us the answer 4. Let's see. 4. Okay, it just counts the number of lines for us. It's just a pretty cool tool that will give you an answer. If you're trying to find out how many occurrences of something there are, that's a really great way to go about finding it. Now, the best thing that you can do here is to play around with things like grep and cut and all that stuff and see if when you create a string, you get the results that you expect. That's really the important part, is play with it, look at the commands that we did. You know what, I'll just paste the text into the description on this video. So if you really want to use the same stuff that I did, you can literally copy and paste it into a text file. But anyway, just play with it to make sure that when you are grepping for something, the results that you get are the results that you expect. And again, don't worry about remembering all the command line flags or remembering all the specifics about regex unless you're taking an exam. In that case, you know, buff up on that right before you go in. Anyway, remember to learn everything, do what you love, and most importantly, be kind. I hope you had fun in this video, and I'll see you at the next one. Oh, and if there's anything else you want me to cover after we're done with this Linux Essential stuff, let me know. I'm making a list of all the cool things I want to cover. It can be advanced, it can be not advanced, it can be even doesn't have to be Linux related. Let me know the sort of things you want me to cover, or you're frustrated and you want me to try to clarify for you. I would love to have a list of things I can make when we're done here. Anyway, I'll see you later.